Okay, so we answered question 1 already, and I'm just going to write it again for you. This is the integral from 0 to 30. This tells us the total amount of traffic that passed through the intersection in the first 30 minutes, and that came out to be 2,474 cars. Okay. Now, in Part B says that it's the traffic flow increasing or decreasing. So remember that this is the function of the traffic flow, how fast traffic's flowing. But the question here is this function increasing or decreasing? When we want to know whether or not this function is increasing or decreasing, that's the question. Is traffic flow increasing or decreasing? So they're talking about, is this function increasing or decreasing? Because this is the function that models the traffic flow rate. So to determine that, we look at the first derivative of this function, and that tells us whether or not this function is increasing or decreasing at time 7. That's the time in question. So f prime at 7, if this number is positive, it's increasing. If this number is negative, it's decreasing. So what we do is we find the derivative of this function at 7. So let's go ahead and go math, option 8. That's how we find derivative. The derivative with respect to x of this function, which is 82 plus 4 sine of x divided by 2. And then we want to evaluate it at 7. And let's see what we get. We get a negative number. So negative 1.8729. So negative 1.873, okay, traffic flow is decreasing because f prime at 7 is negative. Okay, so that tells you that the flow of traffic is going down at time 7. Awesome. What is the average value of the traffic flow from time 10 to time 15? So average value, this is the average value from time 10 to time 15. This is how we set up to find the average value. Okay. Now, let's see what it is. So we have to take the integral, so math 9 from 10 to 15 of the function 82 plus 4 sine of x divided by 2 dx, and that gives us 409, about 409 cars passed through the intersection from time 10 to time 15. We divide that by 5 because that's 5, right? And therefore we get about 82 cars. Okay, and we're talking about cars, so we want to round these numbers up. So 82 cars. So this is about 82 cars per minute. So this is the average. So the average amount of cars that pass through the intersection from time 10 to 15 is about 82 cars per minute. Part D. Part D says, what is the average rate of change of the traffic flow over the time interval from 10 to 15? So the average rate of change of f, and that's different from the average value. So here's how we find the average rate of change of f from time 10 to time 15. So we take the difference between those two values and we divide that by the time interval. So the difference between those two values is going to be, we take f of 15 and we plug that in. An easy way to do that is to program y1 as f of 15. So I'm going to go 82 plus 4 sine of 15 divided by 2, and that's y1. And then I'm going to program y2 as 82 plus 4 sine of 10 divided by 2, and that's 5. But we program it as y1 and y2. Now go to your main screen and then go to vars, yvars, and then call out function y1 and subtract that to vars, yvars, enter, choose y2, subtract those two numbers, and then you get 7.587. So 7.588, because we round up, and then we divide that by 5 because that's 5. So let's divide that by 5, and that's going to give us 1.518. Okay. So this is the number of car per minute square. Okay, so that's the average rate of change of traffic flow from time 10 to time 15.